spout off. I'm just trying to be helpful and I'm not. I'll fix that here in a minute. Okay. Hi, Harvey. All right. Here we go. We're going to list the three-part definition of continuity to determine if these functions are continuous. So this time we don't have pictures. We have expressions. So we're going to have to figure it out a different way. Number one, I need to know that's defined at a certain point. Any clue what that certain point needs to be?
2.
Yeah, -2. Because that's what x is over here. And it is actually defined at -2.
Is it a whole?
No, because it's got right here it says it's equal to -2. So we're good. Its value is f of -2. It would be 3 times -2 plus 2 is -4. So there's the actual value of f of -2. It is defined. Step 1 complete. Number 2 says that what has to happen?
Limits have to be equal.
The limits from both sides have to be equal. So the limit as x approaches -2 from the left, which equation do I use? The top one, because it's x is less than, so that means to the left of -2. So yeah, if I plug in -2, I get the square root of 4, which is 2. 2 times -2 is indeed -4. Limit as x approaches to -2 from the right of which equation? Bottom one, because that's x is greater than -2. I'm betting this one is not going to be. So it's e to the -2 times cosine of -2 pi. Use the negative circle. That's at the point 1, 0. So it's 1. Yeah. So that's 1 over e squared plus 1. So those two limits are not equal.
Okay, that's good.
Cosine of -2 pi, yeah.
So is cosine x or y?
Cosine's x. Therefore, f of x is not continuous at x equals -2. And we can stop there. We didn't have to do number 3 because once you find one that doesn't work, it just doesn't work. Okay, so the next one, we're trying to figure out if g of x is continuous at x equals pi, it says. So we start to see if g of pi is defined. Is there an x where it's pi? Yes, let's see, actually, yes, it is, right here. It's greater than or equal to pi. So it is indeed defined. And g of pi then would be e to the pi times the tangent of 3 pi over 4. I'm going to add a page here. Okay, 3 pi over 4. Got to multiply it by 180 over pi. Pi's cancel. 4 goes into 180 45 times. 3 times 45, 135. Now, 135 degrees is over here somewhere. Which means its reference triangle is 45, 45, 90. That's negative 1, 1, and square root of 2. Tangent is opposite over adjacent. Tell what? So the tangent is 1 over negative 1. So it's negative 1. Did I lose anybody in the process?
So e to the pi times negative 1.
Oh, yeah, I'm sorry. Yes, so e to the pi times negative 1, so that's negative e to the pi. I'm not going to put that there. Put it here. So there's the value. Now number 2, I got to see what? What? Yeah, if there's a limit, if the one-sided limits are equal. So the limit as x approaches pi from the left, use the top one. So that's e to the pi, and then cosine of pi. You need to use the unit circle. Pi is over here. Cosine is the x-coordinate, so it's negative 1. Okay, so e to the pi times negative 1, so it's negative e to the pi. Cool. Limit as x approaches pi from the right-hand side. Yep, e to the x times the tangent of 3x over 4. We just did that for number 1. It was negative e to the pi. Yeah. So there is indeed a limit because they're equal. So then step 3 is that limit equal to g of pi? And it sure is. Therefore, g of x is continuous at x equals pi. That's kind of beautiful. I know. Or not left. I have to keep track of the time because if I make it too long, then I have to do weird things to get it to load. So about 12 minutes, each one works out good. Okay, questions on 4 or 5? Okay, number 6. Consider the function to the right to answer the following questions. We'll do it together. What 2 limits must equal in order for f of x to be continuous at x equals negative 1.
Negative 1 equals and then approach negative 1.
Yeah, so limit as x approaches negative 1 from the left of f of x has got to equal the limit as x approaches negative 1 from the right of f of x.
Is that all that question was?
Yeah. What two limits must equal? Yeah. What two limits must equal in order? I probably need to be a little more specific. I think it's wanting a little bit more. F of x is right, but as x approaches negative 1 from the left, which one is it? It's 2. And as x approaches negative 1 from the right, what would it be?
Plus k.
Plus k. Yeah. I just wanted to be more specific. So what two limits, what if it's 3? Sorry, I don't know how that happened. The limit as x approaches 3 from the left, which equation is that? mx plus k. Yeah, middle. And then that's got to equal limit as x approaches 3 from the right, which is the bottom one, which is negative 2. And then it says, determine the values of m and k so that the function is continuous everywhere. This is a common question on free response questions. Very common. So what you do is basically, since like if you look at that top one, you have two limits that are equal to each other. So you would have to say that 2 is going to equal mx plus k, but in for x, you're going to put negative 1.